In this video, we will learn how to sketch the graph of cosec x and simple transformations associated with it. The question is, what is cosec? Cosec x is the reciprocal of sin x. So the term that we are using is reciprocal. For example, the reciprocal of 2 is half, the reciprocal of 3 is 1/3, the reciprocal of -4 is -1/4, the reciprocal of 2/5 will be 5/2, and so on. When a number is multiplied by its reciprocal, the product is 1. For example, 2 multiplied by half, the product is 1. 3 multiplied by 1/3, again the product is 1. Similarly, the product of -4 and its reciprocal -1/4 equals to 1. The product of 2/5 and its reciprocal 5/2 is equal to 1. So now when we are focusing on cosec x being the reciprocal of sin x, in other words, the product of cosec x multiplied with sin x equals to 1. Now let's pick up some simple values of sine. Sine of 30 is half. Sine of 45 degrees is √2/2 in the rationalized form. Sine of 60 degrees is √3/2. Sine of 90 degrees is 1. And similarly, sine of 180 degrees is 0. And sine of 0 degrees is 0. Let's focus on these four. That means cosec of 30 degrees is 1 over sine of 30 degrees, which is 1 divided by half, which comes out to be 2. Similarly, cosec of 45 degrees is 1 over sine of 45 degrees, which is 1 over √2/2, which flips and become 2 over √2. Similarly, cosec of 60 degrees is 1 over sine of 60 degrees, which is 1 over √3/2, which comes out to be 2 over √3. Naturally, these two can be written in the rationalized form after the rationalization process. Now, when we talk about cosec of 90 degrees, that is 1 over sine of 90 degrees, which is 1 over 1, which comes out to be 1. That means cosec of 90 and sine of 90, they both have the same value, which is 1. We will use this point when we will talk about sketching the graph of cosec. Now let's look at this particular value. Sine of 0 degrees is 0. Sine of 180 degrees is 0. Sine of 360 degrees is 0, and so on. When we talk about cosec of 0 degree, that is 1 over sine of 0 degree, which is 1 over 0, which is infinity. That means cosec of 0 is infinite. Similarly, cosec of 180 degrees is infinite. Cosec of 360 degrees is infinite. So now we will use this idea in sketching the graph of the reciprocal function cosec x. But before we get started with the graph of cosec x, we first have to draw the graph of y is equals to sin x. This is a single cycle of y equals to sin x, 0 degrees, 180 degrees, and 360 degrees. These are the x-intercepts, which means the y coordinate is 0 because sine of 0 is 0. so is sine of 180 degrees, so is sine of 360 degrees. The maximum value 1 occurs at 90 degrees. The minimum value -1 occurs at 270 degrees, and that is the basic idea of a sine function. Now let's draw the graph of y equals to cosec x. So we know that cosec x is the reciprocal of sine x. Let's first draw the graph of y is equals to sine x. I'm labeling the 5 major points. We know that cosec of 0 degrees is undefined. That is the same value of cosec of 180 degrees. That is the same value of cosec of 360 degrees, which is undefined. What should be done at these particular values? What we do is that we draw a dotted line which we label as the asymptote. So there is an asymptote at 0 degrees. There is a vertical asymptote at 180 degrees. There is another vertical asymptote at 360 degrees. So 3 vertical asymptotes can be seen at 0 degrees, at 180 degrees, at 360 degrees. What else is important? We know that sine of 90 degrees is 1 and reciprocal of 1 is 1. Therefore, cosec of 90 degrees is also 1. Similarly, sine of 270 degrees is -1. Reciprocal of -1 is still -1, which is the same thing as cosec of 270 degrees. So let me highlight these two important points. One of them is this and the other one is this. This one at the top is sine of 90 is 1, which is the same thing as cosec of 90. And this point over here for -1 y value, that is the same for sine of 270 and cosec of 270. So I'll further label it like this. This is 1 over here and this is -1 over here. Now when we plug in the values, the graph of cosec goes like this. Up till here, that's a common point, and it goes up like this. Similarly, the graph of cosec goes like this and like this. It's limited between the asymptotes. So it's stuck between the asymptotes. The blue one is the graph of cosec. This blue portion is the graph of cosec, and these two portions make up one cycle. So the blue line is y is equals to cosec of x. Now let me draw it separately, just the cosec. So we can draw it very smoothly by first labeling the asymptotes. So there is an asymptote at 0 and that's how we will draw it directly. And there is an asymptote at this particular value. So this is for 180 degrees and another asymptote at 360 degrees. And remember the wordings. First draw, then label. Yes, we should be drawing the asymptotes first, so as to restrict the graph at 0 and 180 and 360. And then we should draw the cosec graph, which goes like this. So just a curve like this and another curve like this. The minimum value is 1 for the portion between 0 and 180. The maximum value is -1 for the portion between 180 and 360. So that's how the graph of y is equals to cosec x is drawn. Let's apply some simple transformation to the graph of cosec let's draw y is equals to cosec x with a negative sign. Now we know that a negative sign reflects graph in x-axis. That means the original graph I'll draw and then I'll erase it. The original graph is like this and like this. But when we draw the graph of the reciprocal with a negative sign, what will happen is that first let me draw the asymptotes. So there is an asymptote over here. There is another asymptote over here. And don't forget the very original asymptote at the y-axis. So this is 0 and this is 180 and this is 360. It's a thinner graph compared to the first one, does not make a difference. This portion of the graph goes like this. This portion of the graph goes like this. And now the minimum value for the second portion is 1. The maximum value for the first portion is 1. And these two portions, this is basically one cycle of this particular graph. Let's move ahead. Let's draw the graph of y is equals to cosec x plus 1. This is the concept of vertical translation. And because of 1, the graph will be shifted up by 1 unit. So I can draw the original one. First of all, the asymptote. Asymptote is for restricting the graph. That's the first asymptote. That is the second asymptote. And now the third asymptote. And the asymptotes are at 0 and 180 and 360. In white, I'll draw y is equals to cosec x. So cosec x goes like this and another portion goes like this. This is the original graph and it will be shifted up. So y is equals to cosec x plus 1. And let's draw the graph as a dotted line. This green one. And this one will be touching the x-axis, y. Because this point was negative 1, when it is shifted up by 1 unit, it would be touching this particular value. This point over here was 1. It is shifted up vertically to 2. So therefore, the green one is the final one, y is equals to cosec x plus 1. So in this video, what we have learned is to draw the graph of y is equals to cosec x. Cosec is the reciprocal of 1 over sin x, and that's how this graph is formed and drawn.